Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Noor, CD190251. So, we are from group 9. We'll talk about our report. So, the 5 example in real world related with solid. The first one is our case study. We'll talk about buckling on the chair. One of the basic furniture, a chair is type of a chair, and the other side is attached to 3 legs or a tree on which the 4-arm revolving door on the roller can turn strong enough to support the weight of a person sit in the chair and lean on their back. Buckling has become more a problem in recent years as the use of high strength material requires less material for load bearing structures, and components in general become thinner and more prone to warping. So the second one is bridge. Bridge is a type of frame system made entirely of rigid metallic rods connected by pin, such as concrete or steel. For modern truss bridge, truss joint is usually used. Then the bending moment and shear force of the members must be taken into account to evaluate the actual performance. Next one is bending moment and shear force on skateboard. Skateboards are used when the sea is too rough or too calm for traveling, performing stunt as a hobby, and surfing. Shear force and bending moment are examples of combined force generated in structure when a load is applied to the structure. The next one is the slingshot ball. The slingshot ball is small, heavily armed weapon. The classic shape consists of non-elastic hand held wide frame with 2 stripes of tube of natural fiber attached to the upper end. And the last one is thin wall pressure vessel. Thin wall pressure vessel, when designed as tank, are commonly used in industry for the storage and transportation of liquid and gases. A thin wall pressure vessel is a vessel whose shell thickness is much smaller than the general size of the vessel, and the pressure vessel inside is much larger than the outside air pressure. So that's all from me. Thank you.
Introduction. In structural engineering, buckling is the sudden change in shape or deformation of a structural component under load, such as bowing of a column under compression, or the wrinkling of a plate under shear, or the buckling on the chair. Euler's critical load and Johnson's parabolic formula are used to determine the buckling stress in slender column. The chairs are a type of seating which usually four corners of horizontal seating are attached together to our feet that is strong enough to support the weight from the person who is sitting on the chair, and wide enough to hold the lower body from the back and almost to the knee. Their knee perform an angle of 90 degree or lower knee. There are a lot of chairs that have been used today, such as in the living room and dining room. This is the picture of the design of the chairs. So chairs can be made by various of material, and chairs can be made from wood, metal, or other strong plastic such as acrylic, which is strong enough to support someone's weight. There are some chairs that use various types of materials such as wood for the surface of the chair when we sit, a metal for the legs so it can be more strong to support the weight, and the backrests are made out of cotton to make the occupant heads soft. For some chairs, the backrest can be adjusted above the head of the occupant's head, which can make the head more comfortable for resting. The creation of the chairs had helped many people nowadays, and one of a simple design but useful.
Now we go to the problem statement.
So the number one problem statement is how much does the cost to create the chair. Number two, does the chair flexible or rigid? Number three, does the chair ergonomic? Number four, is the material chosen to construct the chair acceptable for the design? And next, tonus for the chair design. Next, does the chair design safe to use daily? And last, is it possible to use the chair for a long period without them becoming brittle or unusable? Next, we go to the objective for this report. So we have fabricate the design, and number two, we have conduct the analysis with the design, and then we have considering the ergonomic of the design. We must to understand the concept of buckling and yield, and we have to calculate the critical load for the chair, and we have to calculate the maximum stress that the chair, and last we have to identify the importance of buckling and yielding in design this chair. So now we go to the scope. So we take from the chapter 3 that we have CDF 3 formula. Formula number 1, we use I equal to BD over power of 3 divide 12. This formula we use to the principal axis of the cross section having the least moment of inertia. Next, we have PCR equal to pi square EI over 4L power of 2. So we use this equation or formula to identify the impact to the chair. And last, we have PC equal to lambda y times E. So this formula we use to determine the buckling load on the support by column during yielding.
Assalamualaikum, my name is Muhammad Irfan Aziz and I will explain about design analysis. This is our design analysis and calculation. We are calculating the chair, the aluminium chair. Analyzing the buckling of the aluminium chair and calculate the maximum load that column can support before it buckles. Here is the chair, aluminium chair, and we have it labeled here. And this is the cross section of the column. This is the data information for the chair. We can see the length of each column here, the area of the cross sectional of each column, B, D, height of chair, and for aluminium chair, we refer to the table. We can get the modulus of elasticity of aluminium. E is equal to 73.1 gigapascal, and the yield strength of aluminium is 414 megapascal. You can see here the label and the data information here. Alright, now first we need to find the moment of inertia to calculate the critical axial load. Here is the formula for the moment of inertia. We just inserting the value here and we get the value for the moment of inertia at the cross section of the column. Now we need to find the critical axial load of the column using this formula here, and then we insert the value pi, and here we insert it from the data we get before, 73.1 gigapascal, and the inertia divide by 4 times with L. L is the, let me check. Yeah, L is the length of each column, 45 centimeter equal to 450 millimeter. We are using millimeter. Every value here we are using millimeters. So we get the critical axial load for the chair of the column 679,382.30 Newton. After we find the critical axial load, we going need to find the buckling load. The buckling load using the formula here, PC is equal to tensile strength times width area. We just insert the value, the area of the cross section, and we get the value here. The buckling load is equal to 125,000. Oops, sorry, pardon. It is 1,252,350 Newton. And we can see that the buckling load, and we comparing buckling load and critical load. The critical load is smaller than buckling load, which is going to be a problem because it will break the, it will make the chair to break because of the buckling load is bigger than critical load. So we need to find the ideal height for the chair to improve the buckling using the formula here. The original formula should be PC square is equal to here pi square EI over 4H over 4H. Yeah. But we rearrange it and we put it here. Now to calculate the ideal height, we using this form, we insert the value. PC here we are using the buckling load, so we can get the ideal length for the buckling load. And we get the length of the chair is equal to 321.44 millimeters, equals to 33.14 centimeters. Okay, that's all for the calculation. Thank you.
Okay, Assalamualaikum Doctor. My name is Muhammad Azhar bin Muhammad Aziz. Number matric is CD190229. Okay, I will explain about the discussion of our project. Based on the project that we has been made, we has used material of aluminium for our chair. Based on this material, we managed to calculate the specific amount condition of the chair. In this project, we also has achieved all our objective for this project. Okay, for this calculation, we has been used three formula, which is moment of inertia, critical axial load, and the buckling load. To know at what state that the column will buckle, we have to calculate the moment inertia first, and we get to 762,552.08. After that, we have to calculate the critical axial load, which is 679,382.30 Newton. Lastly, we calculate the buckling load and we get 125,2350 Newton. From this calculation, we has comparing the critical axial load with the buckling load. We can see that the critical axial load is smaller than the buckle load. So, it means the column of the chair has been buckled due to overload. Because of the problem, our group has come up with a solution to find the ideal height for the column chair. The calculation has shown and we get the answer 33.144 cm. With this height, there is no issues more about buckling because the calculation has shown the ideal height for the column of the chair, and we think this chair is suitable for the kids because the height is too short and not suitable for the adults. Lastly, we can conclude that if buckling is happen to the chair, so it is because the critical load has been exceeded. Okay, thank you.
Conclusion. From this project, we can conclude that using the second condition from Euler's equation and critical load, we get the maximum load of 125,2350 Newton. Also, material is important in this project besides the calculation. Without a good materials, the chairs may not be able to support the weight on the seat. Design is also very important to choose beside the calculation and material. Design that we choose in this project are using aluminium, which is strong enough to accommodate the occupant's weight. The design using aluminium is the best because it can stand a maximum load.